Hello, this is Mrs. Taylor, and I am going to review factoring by using the box method. So in class, we learned that if I am asked to multiply two polynomials, I can use the box method to do that. And through that work, we realized there was a pattern, and we've used that pattern to factor trinomial or quadratic trinomial equations. And so I'm going to demonstrate for you that factoring. This is an example of when a equals 1. And the reason it's an example of when a equals 1 is because when we learned in class about quadratics, we learned that there was a standard form. It was y equals ax squared plus bx plus c. And so the coefficient that's in front of the squared term is referred to as a. And when it is 1, 1 times x squared, it's just x squared. And so it looks like there's no coefficient for the squared term, even though we understand it to be 1. So in our example here, we have x squared plus x minus 12 equals 0. And if you look, there's no number in front of the x squared, and we understand it to be 1. So a equals 1. And so when a equals 1, factoring can be a little easier. So to use the box method, of course we need a box. And when we factor these trinomials, we know that our polynomials are binomials, 2 by 2s. So 2 rows, 2 columns. And when we're factoring, we fill in the inside boxes first and then move to the outside. So we always know that the squared term is always in this top left box. And my constant term is always in the bottom right box, this minus 12. The other patterns that we've noticed that help us factor are what happens with the two boxes that are empty here. These two boxes, if I have filled in my box correctly, will always have a sum and a product that are specific. So what I mean by that is if I add these two boxes, I should get a sum that's equal to the middle term of my trinomial. And just as we said before, it's x, but we know that really it's 1x because there's a 1 understood to be there. The product of these two boxes will always multiply to equal what the opposite diagonal multiplies to equal. So what I mean is that if I multiply diagonally this direction, I should get the same result as multiplying diagonally this direction. X squared times negative 12 is negative 12x squared. Now when we are working through factoring, we focus in on the coefficients, the 1 and the negative 12, because we know that these boxes will have an x. And that takes care of the two boxes adding to an x here and multiplying to an x squared here. Really, all I'm looking for, the puzzle part, is trying to figure out what the numbers are. So the easiest way to approach this is to think of factors of your product, so negative 12, that add to your sum of 1. I'm going to make a list of the factors of negative 12. There are several. You could have 6 times 2. Of course it's negative, so it's actually negative 6 and 2, or negative 2 and 6. You could also have negative 4 and 3, or negative 3 and 4. And then of course negative 12 and 1, or negative 1 and 12. And in case you didn't guess from my list, factors are two numbers that multiply to equal whatever the number that you're factoring. And these are all the possible factors of negative 12. Now the pair that I need to put into my box is the pair that not only multiplies to negative 12, but adds to this sum of 1. And through using my calculator or my integer rules, if I add these pairs, I will find that only one pair adds to a positive 1. I almost circled negative 4 and 3, but negative 4 plus 3 is negative 1. We want positive 1. So negative 3 and 4. So that tells me that this is actually a negative 3x and a 4x. Now many students ask, did it matter that I put a negative 3 here and a 4 here? Could I have easily put 4 in this box and negative 3 in this box? Absolutely, because the next step works regardless of where you put your, and we call these linear terms or x terms because they only have an x. So my next step is to look for GCF, that's greatest common factor. So for example, this list is a list of factors. If I was comparing 12 to another number, I would look for their greatest common factor. They may have several common factors, but the greatest is only one. So for example, if I look across the top row here, x squared and 4x, we understand that there's a 1 in front of this x squared, and 1 and 4, their greatest common factor is 1, because 1 can only be factored with 1 times 1. 4 has a few factors, 4 and 1, or 2 times 2. But the one that's common is 1, and it is the largest factor that they have in common. In addition to the numbers, x squared and x, they have a greatest common factor of x, because both terms have x in them. So my greatest common factor would be 1x, or you can just write x. And the reason we're doing this is because when we pull these greatest common factors out to these sides here outside of the box, that's where I get my factors that they're asking me to find in this problem. When I look down the first column, the same thing is true for GCF. It's 1x. Factors of 1 are still 1 and 1. Factors of 3 or negative 3 are either negative 3 and 1 or 3 and negative 1. And the way I know if my GCF is positive or negative is I refer to the box it's closest to. Each of these factors, these GCFs, are on a positive box, so they will be positive. If I look across the bottom row, 3 and 12. Well, the factors of 3 are 1 and 3, or negative 1, 3, negative 3, 1, because this is a negative number. If I look at my list of factors of 12, 12 has several factors, but the factors that are common with factors of 3 are 3 and 1. So the greatest common factor between 3 and 12 is 3. Now, in addition to that, the box that this GCF is next to is negative. So that tells me that the GCF should be negative as well. The last GCF I have to find is for this right column, 4 and negative 12. The factors of 4 are 4 and 1, 2 and 2. I'm going to write these down here so we can look at them in comparison to the factors of 12. So we have 2 and 2, or 4 and 1. Between 12 and 4, which are my two boxes here, there are several common factors. 2, 4, and 1 are in each list of factors for 4 and 12. However, the thing to keep in mind is that even though they share 3 common factors, there's only one greatest common factor. And that would be the largest number, which in this case is 4. So the GCF for this right column is 4. And it is positive because the box that it is closest to is positive. Now that I have that information, what I do is I look at my perimeters, and I now have the terms of my factors. And typically you don't see people write the 1 here next to the x. You're welcome to do it as a placeholder, but you may not see others do it. So my factors are 1x plus 4, because this was a positive 4. I'm just going to write it as x plus 4. And then my factors down the left side are x minus 3. Now, one thing I haven't addressed yet is this equal 0 part. It says solve. And when we solve quadratics, it can be tricky, because if we tried to solve them the same way we solve linear equations, it would be really difficult to isolate the x. But once I've factored, it's easier because of the zero product property. The zero product property says that if I multiply anything times 0, the entire product is 0. And using that idea and the idea of factors, these two sets of parentheses, these two binomials, are being multiplied. Together, their product should be 0. Well, if just one set of parentheses, just one binomial equaled 0, the whole result, the whole product, would be 0. So I use that zero product property to separate my factors, x plus 4 and x minus 3. And I set them set them equal to 0 separately. And the reason I do that is because I know that if just one of those factors equals 0, my entire product would be 0. So I can solve this equation by solving these factors individually. Subtract 4 from both sides for this factor. Add 3 to both sides for this factor. And so my solution, my result, would be x equals negative 4 and x equals 3. And another pattern that we notice is that the solutions are the same as the constants in my factors, except for they are the opposite sign. So I had plus 4 in the factor, minus 4 in my answer. Minus 3 in the factor, positive 3 in the answer. So that's how you would solve a quadratic equation by factoring using the box method when a equals 1.